All right, let's distinguish between coordination number, coordination bonds, and Ligand number. We won't discuss theory now. Theoretical concepts aren't very useful for high school problems. Let's focus on understanding through examples. Let's look at the first one, which asks about coordination number. Before finding the coordination number, we need to identify the central atom, which is copper, right? Then we look at how many bonds extend from the copper central atom. That's how many coordination sites it has. How many? Count 4. So the coordination number is 4. Now, what about coordination bonds? Generally, coordination bonds equal coordination number. But note, this is only true in most cases, except for 295, okay? So you see, its coordination number is 4, and its coordination bonds also number 4. Now, what about ligand number? For ligand number, after finding the central atom, look at the connected molecules, ammonia in this case. How many ammonia molecules are connected? It has 4 connections, so its ligand number is what? It's 4. Remember, ligand number refers to monomer units, coordination number refers to connected atoms, okay? Let's look at the next example. This special dimer, iron dichloride. In this compound, who is the central atom? It's iron. Note, there are 2 iron atoms, but when analyzing, we just focus on one, understand? You need to be clear about which atom you're analyzing. Now, for coordination number, how many bonds does it have? It has 4 bonds, so the coordination number is 4. What's important here? What about its coordination bonds? How many coordination bonds does it have? 12. Why? Look at this diagram. Notice the chlorine atoms aren't all the same. These 4 chlorines on the sides are single bonds, but what about the chlorine in the middle? It forms double bonds, right? It connects to 2 bonds, not double bonds. It connects to 2 separate bonds. These 2 bonds, see, should count as one coordination bond. Originally, we had 1 iron chloride, 1 iron chloride. So what happens when they combine? How do they dimerize? What holds them together? They're held together by these coordination bonds. So the number of coordination bonds here is important. How many are there? 2. The Ligand number, or after finding the central atom, look at the connected monomers. How many? Counted 4. Okay, let's look at the third one, which is the central atom. Silicon. Then the coordination number, count it. It comes from above to make a structure. Count 1, 2, 3, 4, 5, 6. Coordination number is 6. Coordination number is generally counted. They're equal except for dimers. Just equate coordination number and coordination pieces. Just look at the equivalent. For ligand number now, after removing the central atom, the structure now becomes this. What is this? A ligand. This is a ligand. Don't just see 2 pieces connected, but what I mean by ligand is what? The connected monomers. This is one monomer. This is also one monomer. This is one monomer. This is one monomer. So its ligand number is 4. Okay, moving on. Same central atom, coordination number 4 sites, 4 pieces. Coordination piece count is also 4, right? Now let's talk about ligand number. Remove the same and look, is this side a monomer? Is this side a monomer? Okay? So what's the ligand number? Counted 2. No problem here. Let's look at the next one. Again, central atom is silicon, connected to 4 sites, 4. So coordination piece count is also 4. Ligand number is 1, 2. Have you noticed anything special? How are they? They look the same. So if they look identical, is it 1 ligand or 2 ligands? How many? 2. Note, ligand number has nothing to do with whether they look the same or not. I just count how many monomers I've connected. Let's compare with the one above. You see it's 2 identical monomers, right? What about the 4th figure? Look, it's 2 different monomers. Whether it's 4 or 5. What's the ligand number for both figures? Both are 2, okay? It has nothing to do with whether your ligands look the same or not. It's about the number of monomers you've connected. Let's look at the 6th one. Central atom is silicon connected to 4 pieces. So its coordination number is 4, and coordination piece count is also 4. For ligand number, after removing the silicon, we find, how many is this? It's 1. So what's its ligand number? It's 1. From 1 monomer, 4 coordination pieces are connected to silicon. Understand? Let's look at the last one. Silicon. Central atom with 4 pieces. Coordination number is 4. Its coordination piece count is also 4. What about ligand number? Remove silicon, you see it's still 1. Ligand number is 1. Can you distinguish now? Very simple. That's it.